All right, this is a screencast for those of you who missed class on Monday, December the 9th. And this bellwork, I call it bellwork, but it's pretty much classwork because we did this for most of the period. So, first situation, we have a rocket that is being launched. So we've got the rocket moving up. We've got it expelling the exhaust gases from the fuel that it's burning, coming out the bottom. And just to remind you before we go into this, Newton's third law of motion says that for every action, there's an equal and opposite reaction. In other words, for every force, there's an equal and opposite reaction force. And I think in your book, it actually says something like, when one object exerts a force on a second object, then the second object is going to exert an equal and opposite force back on the first object. Okay? But in other words, when one object exerts a force on a second object, then the second one's going to exert an equal and opposite force back on the first. So, if the action force is stated, the rocket pushes the gases down, then the reaction force is going to be basically stating just the opposite. So, for instance, if object A pushes object B down, then object B is going to push object A up. Okay? So with that in mind, the reaction force, we're just going to restate this basically in the opposite way. The reaction force will be the gases push the rocket up. Okay? And then it's tempting to say that one force is bigger than the other because you see the gases coming out really, really fast when a rocket launches, and you see usually a rocket going up fairly slowly at first. And so it's tempting to say that the forces are not the same. But remember that Newton's third law says for every force there is an equal and opposite reaction force. So which force is bigger? Neither one. The forces are equal. Now, the reason why it doesn't seem like things are the same is because, well, there are some things that aren't the same. The forces are the same, but the rocket and the gases, their masses are different, so their accelerations are also going to be different. And remember, which things are going to accelerate more? Well, little things, light things. So which object accelerates more, the rocket or the gases coming out as exhaust? Well, which one has more mass? The mass of the rocket is big, so its acceleration is small. The mass of the fuel is small, so the acceleration of the gases from the fuel is big. All right, so let's write that in, and then we'll move on to the next one. Okay, and before we move on, let's just take a look at our two arrows. These are representing our equal and opposite forces. If we take a light blue for the action force, that is the rocket pushing gases down. So that's this one. The reaction force I'll do in red. The reaction is the gases push the rocket up. That's this force. Okay. But again, the forces are equal and opposite. All right, next we have Joe Bob and his car. Joe Bob left a box on the top of his car. If Joe Bob hits the gas hard enough and just takes off suddenly, what will happen to the box? Well, this is similar actually to that old tablecloth trick that hopefully you have seen the video for at this point. But if you haven't, make sure you watch it. So the car is going to move quickly, I suppose this way, although my car, the front and the back kind of looks the same. But let's just assume that that's the front, and the car takes off that way. The car's going to take off, but the person hitting the gas, that's going to move the car. That's not going to move the box. So the box will basically just fall down, but the car has moved in the meantime. So the box is going to land behind the car, okay? So the box will land behind the car, and that's basically because the inertia of the box is not going to move very much, even though the car has moved forward. So basically, the car is going to move out from underneath the box, and the box is going to fall, and the box will land behind the car. Okay, so that's the situation with Joe Bob and his box and his car. So the box is going to land behind the car. The inertia of the box prevents the box from moving very much, even while the car is moving forward. So basically, the car moves out from under the box. Okay. All right, our next situation, we have a ball that's dropped. And the action force is stated, earth pulls ball down. Okay, with a force equal to the force of gravity. It's very tempting for people to come up with something creative here because they really don't think, oh my gosh, that involves the earth. Certainly it's got to be different or something. But remember, if the action force is stated A pushes B down, then the reaction is B pushes A up. Okay. Earth pulls ball down. Reaction is just the opposite. Ball pulls earth up. Really? Can the ball really do? Yes, it can. Now the earth is so massive that basically, the acceleration is going to be nothing for the earth. But yes, the forces between the two are equal and opposite, believe it or not. Okay, and I cannot emphasize enough. I know that it seems to you like, oh my gosh, the forces can't possibly be the same because I see something happening to the ball, but I don't see anything happening to the earth. Well, that's because the ball is really, really small compared to the mass of the earth. So even though you don't seem to think that things, that forces involved are equal, they are. The masses aren't the same. You're talking about a little bitty baseball versus the size of the earth. Okay, so the masses aren't the same, and so the accelerations aren't going to be the same either. But the forces are the same. Okay, so which object accelerates less? Is it the baseball or is it the earth? Well, obviously it's the earth. The earth is going to accelerate basically not at all. Why? Because the earth is super huge. It's like 6 times 10 to the 24th kilograms. That would be 6 and then like a whole string of zeros before you even get to the decimal place. It's a huge mass. Okay? So the earth is basically not going to accelerate at all. Okay, so action, earth pulls ball down. Reaction, ball pulls earth up, even though I didn't draw the force pulling the earth up. Which force is bigger? Well, they are equal. Remember, Newton's third law says for every action force, there's an equal and opposite reaction force. Which object accelerates less? The earth. Why? Because it's got a huge mass.